Bernoullis' theorem has been used for many years to explain how a wing creates lift. It is not the only theory used to explain this phenomena, but as it is still most widely used in aviation exams, we will cover it here. Remembering what we just learned about static pressure, let's see how that relates to the production of lift. His theorem states, within a horizontal flow of fluid, points of higher fluid speed will have less pressure than points of slower fluid speed. The fluid he's referring to for our purposes is air, as air is indeed classed as a fluid. A venturi is a cylinder, exactly like you see here, which has a decrease in the size of the cylinder in the middle. Let's take a particle, a molecule, same thing, of air. It will enter the venturi from our left side. It will get to the narrowing in the middle. If it is to pass through the narrowed middle with the same amount of air as when in the left side, it will need to speed up to achieve this. Remember, that need for the air to speed up is to get the same volume of air through the smaller middle as went through the opening. We've now got our indicator to show the speed of the airflow, and our gauge to show our air pressure, which is on the right. And our air molecule with all its friends trying to enter the venturi, is on the left. As our friends get going, we can see the constant air speed and constant air pressure. As it nears the narrowing, it's going to speed up. The pressure drops as it speeds up, and as it reaches the other side, the airspeed decreases due to the larger cylinder, and the pressure increases again. And it's now back to how it was before it reached the narrowing. It's the very same relationship between airspeed and pressure that we were looking at. So this is all fun, but the question we need to answer is, what causes lift? And to explain that, we can turn the venturi into a cross-section of an airfoil. This airfoil is now our wing. The different shapes of the upper and lower surfaces lead to differences in the relative speed of air flowing over them. The air separates as it reaches the front of the wing. Part of it goes over the top, and part of it goes underneath the wing. The theory is that the air traveling over the top of the wing has to travel further than the air underneath the wing. This is due to the lump on top of the wing. As the air flows over the top of the wing, we produce a low pressure due to the airflow having to speed up. Once again, it speeds up due to the air on the top and the bottom having to take the same amount of time to get to the rear of the wing. Theoretically, the air parts at the front of the wing, and the top has to travel faster to meet the bottom flow at the rear of the wing at the same time. The word velocity can be used to describe our vector. Velocity means the speed something is traveling in a given direction. So a greater velocity would mean a greater speed. With an air velocity increase, static pressure decreases, resulting in a static pressure differential above and below the wing. We now have a lower pressure on top of the wing, due to the increased air speed. And we have a higher pressure below the wing, as it hasn't really had to change its speed, or to use another word, its velocity. That is how lift is produced.